Ever wondered how we can make it rain? It's a question that has baffled humanity for centuries. Rain is more than just a weather phenomenon. It's a lifeline. Water, in the form of precipitation, is critical to life on Earth. It quenches the thirst of every creature, nourishes the soil, and fills our rivers and lakes. But how does it form? The secret lies in the clouds. They're made of tiny water droplets or ice crystals that form around particles of dust or salt in the atmosphere. Without these particles, raindrops or snowflakes simply cannot form. But what if we could control this process? Enter the intriguing world of cloud seeding, a technique that enhances a cloud's ability to produce rain or snow. By introducing tiny ice nuclei into certain types of sub-freezing clouds, we can stimulate the formation of snowflakes. So how exactly does this fascinating process of cloud seeding work? Cloud seeding is an intriguing technique, but it's not magic, it's science. Just as a pearl begins its life as a grain of sand inside an oyster, a raindrop or snowflake starts its journey as a tiny particle, called a condensation or ice nucleus, floating in the atmosphere. Without these nuclei, precipitation as we know it wouldn't happen. Now let's introduce cloud seeding. This weather modification technique boosts a cloud's ability to produce rain or snow. Here's how it works. Tiny ice nuclei are introduced into certain types of sub-freezing clouds. These added nuclei serve as a base for snowflakes to form. Once cloud seeding occurs, the newly minted snowflakes grow rapidly and fall from the clouds back to the Earth's surface. This process increases snowpack and streamflow, which can be beneficial in areas where water supplies are low. So where does silver iodide come into play? Most cloud seeding operations, including those conducted by the Desert Research Institute or DRI, use this compound to assist in the formation of ice crystals. Silver iodide naturally exists in our environment at low concentrations and is not known to harm humans or wildlife. When a storm system moves through a cloud seeding project area, a solution containing a small amount of silver iodide is burned from ground-based generators or released from aircraft. Once it reaches the cloud, the silver iodide acts as an ice-forming nucleus, aiding in the production of snowflakes. Cloud seeding operations typically run during winter seasons, between November and May, when storm systems are actively moving through project areas. However, during dry winters, when storm systems are absent for long periods, cloud seeding can't occur because, well, you need clouds filled with moisture for seeding to work. Cloud seeding is a scientific process, reliant on specific conditions and monitored by experts, including meteorologists who watch the weather throughout the season for optimal cloud seeding conditions. It's important to note, they avoid times when additional precipitation could be problematic, such as periods of high flood risk or during heavy holiday travel. Now, let's dive deeper into how this process is implemented. Cloud seeding can be done from the ground or the air, depending on the situation. Ground-based generators, which can be operated remotely, are often the preferred choice. These generators are typically designed and built by weather research institutes, such as the Desert Research Institute, or DRI. In certain areas, like the Carson and Walker River basins, cloud seeding is also conducted from a subcontracted seeding aircraft. Most cloud seeding operations use a compound called silver iodide to aid in the formation of ice crystals. This compound exists naturally in the environment at low concentrations and is not known to be harmful to humans or wildlife. When storm systems move through a cloud seeding project area, a solution containing a small amount of silver iodide is burned from ground-based generators or released from aircraft. Upon reaching the cloud, the silver iodide acts as an ice-forming nuclei, aiding in the production of snowflakes. DRI's cloud seeding operation generally runs during the winter season, from November to May, when storm systems are actively moving through their project areas. However, during dry winters when storm systems are absent for long periods, cloud seeding cannot occur. This is because cloud seeding requires the presence of moisture-filled clouds. An essential part of the process is the team of weather experts, including meteorologists, who monitor the weather throughout the season for appropriate cloud seeding conditions. They ensure that cloud seeding does not occur during times when additional precipitation would be problematic, such as times of high flood risk or during busy holiday travel periods. So, the process of cloud seeding is a well-orchestrated symphony involving ground-based generators or aircraft, a silver iodide solution, and a team of meteorologists. Together, they work to enhance the ability of clouds to produce rain or snow, and ultimately increase snowpack and stream flow. But one might wonder, why go through all this trouble? What are the benefits of cloud seeding? Cloud seeding isn't just a fascinating scientific process. It offers tangible benefits. Imagine a winter where snowfall is enhanced, creating a winter wonderland that not only delights the eye, but also significantly contributes to mountain snowpack. This is the magic of cloud seeding. Now, why is this increased snowpack important? Well, it is because it directly supplements the natural water supply available to communities in the surrounding areas. In a world where water scarcity is a growing concern, this technique serves as a game changer. Studies show that long-term cloud seeding projects, like those conducted over the mountains of Nevada and other global regions, have increased the overall snowpack in targeted areas by 10% or more each year. Even in the rugged ranges of Wyoming, a decade-long cloud seeding experiment led to a 5 to 15% increase in snowpack from winter storms. Cloud seeding is a powerful tool that can help us manage our water resources more effectively. The impact of cloud seeding is significant and has been proven in various parts of the world. For instance, in the mountains of Nevada, long-term cloud seeding projects have demonstrated an increase in overall snowpack by 10% or more annually. This has led to a substantial boost in the natural water supply, benefiting the surrounding communities. Similarly, a decade-long cloud seeding experiment in Wyoming's Snowy Range and Sierra Madre Range resulted in snowpack increases of 5 to 15% from winter storms. Furthermore, research from a cloud seeding program in Montana's Bridger Range showed snowfall increases of up to 15% using high-altitude remote-controlled generators, similar to the methods employed in modern cloud seeding projects. Seeing these success stories, it's clear that the potential for future use of cloud seeding is immense. The next time you see rain, remember that perhaps it's not just nature at work, but also the hand of science, making it rain through cloud seeding.